Listening Practice 4.
Listen to part of a lecture in a physics class. As you listen, try to complete the notes below. Then use the notes to help you answer the questions.
Okay, as you know, inertial energy, the total energy of an object in motion, is equal to its mass times its velocity. That means that even a very small object can have an extremely high inertial energy if it is moving fast enough. Today we're going to talk more about that, specifically about the physics of impacts at ultra-high speeds. The speeds I'm talking about are those exceeding 7 times the speed of sound, what are called hypervelocities. Okay, so at around 5,000 miles per hour or higher, the inertial energy of an object far outweighs its structural strength. At these speeds, even the hardest metals behave somewhat like liquids. On impact, all that inertial energy, or at least a great deal of it, is converted to heat energy. Both the impactor and the target will liquefy as a result, and if the velocity of the impactor is high enough, they may even vaporize. So you can see that such a collision can be incredibly destructive. Now, on Earth, the physics of hypervelocity impacts don't often come into play. Not even bullets travel this fast. Where hypervelocity impacts do come into play is in space. Take, for instance, your average satellite in a stationary orbit around the Earth. It's going to have a speed of around 22,000 miles per hour. That's well into the hypervelocity range. So let's say that satellite hits something in space, a meteorite or maybe a loose bolt from another satellite, whatever. Even a collision with the smallest object could be catastrophic for the satellite. And the thing is, there's not much point in trying to shield the satellite because, as we said, at these speeds, inertial energy far exceeds the strength of basically any material. Another point is that at extremely high temperatures, like those produced in a hypervelocity impact, materials may vaporize and enter a plasma state. Plasmas are gases that hold an electrical charge. So even if the impact doesn't completely destroy the satellite, the plasma it creates may knock out all the electronics on board.